Example 3.1.5, determine the angular rate of rotation necessary to produce a 60 Hz voltage or current waveform in a synchronous generator with 8 poles. So in this, red ink today. Switch it to black, sorry about that. Given the fact that we have a 60 Hz electrical frequency and we have 8 poles, the symbol for poles is capital P. We're needing to find the angular rate of rotation, so that's omega m, right? Omega radians per second. So how fast is this thing spinning? The solution to this is fairly straightforward. There is a fixed relationship in a synchronous generator between electrical frequency, the mechanical rate of rotation in RPMs, and the number of poles in a generator, and we just take the RPM, we multiply it by the number of poles, we divide by 120, that gives us electrical frequency. So we would set this equation up to say 60 Hertz of electrical frequency is equal to N times 8 here. We need to divide that by 120, so that tells us that N is equal to 120 times 60 divided by 8, and that gives us a value of 900 rotations per minute, or RPM. So that is not angular rate of rotation, though. We need to determine angular rate, and we take that by multiplying 2 pi over 60 times the mechanical rate of rotation. So that's going to be equal to 2 pi over 60 times 900, or you can multiply by pi over 30. So this is going to give me 94.25 radians per second. And if you're curious where that conversion comes from, remember, one complete circle is one rotation, and that equals 2 pi radians, and then 1 minute is equal to 60 seconds. So that's where this conversion factor came from right there.